Welcome to the Control Engineering Webcast, VFD Configuration and Troubleshooting with a Smartphone, 10 Tips, 3 Applications, and a Demo, sponsored by Yaskawa. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering, Plant Engineering, and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type answers for our speaker in the Ask a Questions box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand webcast. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of the webcast. I'm happy to introduce today's distinguished speaker. Michael Hall is the Product Manager for Mobile Applications and Technical Communications for Yaskawa America Incorporated, the world's largest manufacturer of AC inverter drive, servo and motion control, and robotics automation systems. He has worked in the AC drive business for more than 20 years, and his roles have included product engineering, application engineering, and field service. Now he's leading Yaskawa's mobile application initiatives and has made it a priority to develop and evolve tools that exemplify ease of use and make the complicated simple. Michael spent the last decade focusing on technical communication and is a proud member of the Society for Technical Communication Professional Organization. I'm your moderator, Mark T. Hosky, Content Manager for Control Engineering, CFE Media and Technology. Michael, please go ahead.
All right, thanks, Mark. And thanks to all in attendance today. I really appreciate those that dialed in, and I'm excited to talk about this topic. One interesting fact I'd like to kick off with and just touch on briefly, this topic is related heavily to variable frequency drives that use electric motors. And an interesting fact is that electric motors use 45% of global electricity. For industry in the U.S., motor-driven systems use about 68%, and that's really about 2,800 tera BTUs of direct use of total electricity for essential like applications such as refrigeration pumps, fans, compressors, those types of things. So a VFD is typically the best way to reduce energy use, improve process control, automation, and diagnostics in those applications. Another interesting fact is that more than 1.6 million VFDs or AC drives have been sold in the U.S. in calendar year 2018. That's a lot of VFDs. This is according to NEMA, the National Electric Manufacturers Association. How many of these are connected to the internet today? How many can be started up or you can do troubleshooting with your trusty smartphone? Let's make sure we're ready for the evolution of what's going to be happening here and is happening today with mobile apps and VFDs. Now, even though I mentioned the internet, this session is not about the Internet of Things or IoT. The internet does help us communicate, store, retrieve useful information in ways that can simplify our lives. There are opportunities here to simplify how we work with VFDs. In this session, we will learn different ways smartphone apps for VFDs paired with even a Bluetooth connection can simplify VFD configuration and troubleshooting. So why would we use our smartphones with a VFD? So manufacturers design HMIs or keypads for VFDs that find a balance between what's needed to use the VFD and cost. Now, manufacturers design HMIs to balance cost and user needs also. So these HMIs see most use during initial setup or diagnostics of the VFD. Some facilities that have a lot of VFDs installed will communicate with their VFD over an industrial network. In some facilities, the HMI is actually rarely used except for initial setup. For other VFD installations, that HMI that comes mounted on the front of the VFD is used very frequently and is actually the sole means of interacting with the product. Whether we use the VFD's HMI frequently or infrequently, wouldn't it be great to be able to use our smartphone, a device that most of us use every day, to work with these VFDs? Here I'm showing a couple of example layouts for some typical HMIs for VFDs. Some of you in the audience may recognize these in products that are sold today. As you can see from looking at these, the designs can vary quite a bit. Lower cost, small capacity VFDs may have limited featured HMIs with limited displays or fewer buttons. This is actually a result of a fine balance between the VFD features and the intended application for the VFD. Looking at the examples, we do see some extremes here. Fewer space, smaller buttons, compared to the more advanced VFD HMI on the right, which is used for more complex or even what we would call general purpose applications. Often manufacturers will provide an option to take this, a more advanced HMI or full-featured HMI and use it with a more simple VFD. Mobile apps for VFDs can be full-featured regardless of the type of HMI that comes provided with the VFD. I think I should, even though this presentation is about mobile apps for VFDs, I don't want to neglect PC tools. And PC tools for VFDs are great. There are some challenges, though, with using PC tools and a VFD. A lot of manufacturers will offer PC tools that interface with the VFD. This wasn't always the case. If you can think back to maybe the early 90s where PC tools for VFDs weren't all that common. That often left the user to decipher the cryptic HMI with no other option. Fortunately, over time, a lot of VFD manufacturers have evolved in what they offer for PC tools. So first, though, you have to have a laptop, and that can be expensive. However, one can argue that the price for the latest iPhone Pro is comparable to a new laptop if you've looked at that today. And I'm not dinging iPhones, I actually have one. We may not want to expose our laptops to harsh environments. So where smartphones are often made for our daily use and to tolerate harsh environments. Setting up a laptop can be time consuming, like to take it out, plug it in, find a spot to rest it on, connect the various cables or cable required, and it can be inconvenient in an industrial environment. Taking a laptop in a difficult to access or cramped locations, such as inside ductwork or around moving equipment, can also be challenging. So making a wire connection between the laptop and the VFD could subject that laptop to damage during a power surge, for example. And at my firm, we recommend using an optically isolated USB connection between the VFD and the PC tool. So let's talk about a little bit here the difference between using an HMI keypad now and a mobile app. So there's very skill sets and technical knowledge required to use a VFD and learn its HMI, especially if you're a new user and you're just getting exposed to that VFD. A mobile app could be easier to use and more friendlier than an HMI because, the mobile app and its interface are something that we're very familiar with and most of us use every day. HMIs can vary significantly between manufacturers. It can take time for, like I said, for new users to learn specific HMIs. And a mobile app may be especially beneficial for first-time installers, new equipment operators, or even maintenance personnel. An operator or facility technician may have infrequent or limited exposure to a VFD's HMI, and they may only see that VFD and its keypad or HMI for installation or troubleshooting activities. A lot of users don't spend a lot of time standing in front of the VFD and looking at it. If the VFD is doing its job, it's almost a set it and forget it type of equipment. And you may not even see a VFD or have a chance to interface with it for years after it's installed. So again, a smartphone is a device that we use every day. You combine that with a mobile app, and that can actually simplify those times when we do interact with the VFD. Let's talk about some of those benefits that a smartphone can offer for use with a VFD. So smartphones or tablets with a mobile app can provide an ideal platform to communicate and operate and actually troubleshoot and use the VFD. We know that VFD manufacturers are trending towards mobile applications for these VFDs, and they're trying to leverage some of those benefits and that familiar interface for use with their products. And some of those could be the high resolution, high contrast displays, more intuitive interface via software. It's readily available. It's in your pocket. It's portable, right? And let's not forget harsh environments. How many of us has dropped our phone on the ground or in the snow up here and where I'm located, or forbid even that place that we dare not speak during the session here. These devices often recover unscathed from our harsh treatment. And lastly, a smartphone platform is agnostic to the VFD to which it's communicating. So what I mean by that is a single smartphone can have many apps from varied VFD manufacturers installed on it, and as long as that manufacturer does provide a mobile app for their VFD. And again, most of us have one of these mobile devices and we use it every day. So let's talk about some examples of a VFD mobile app and some displays. And I took some samples here from one that I'm familiar with. As we can see, there are clear advantages of using this mobile app for VFD configuration and troubleshooting over an HMI supplied with the VFD manufacturer. Think back to the samples of the HMIs that I showed earlier. So mobile apps are, they're touch screen also versus directional arrow keys on an HMI. We can get more detail out of a mobile app display compared to the limited display area of an HMI. And mobile apps, if they're well designed, are more intuitive and full-featured compared to an HMI. Some of the other benefits is once you get a mobile app on your phone, you can actually leverage internet access or even cloud access to safely back up and store VFD settings. And that's one of the screenshots that I've provided here as a sample of that. And the other benefit is the mobile app the mobile device has wireless or Bluetooth technology built right into it. And that has many benefits that we're going to talk about for accessibility and safety. So the touchscreen versus directional arrows, you can get more information on the display. It's intuitive, we're familiar with it, and it may be easier to learn. And we can have features in there that don't lend themselves to be designed into an HMI interface on a VFD. Wireless access, again, I'll hit on that. It can improve accessibility and safety when working in or around the VFD. So let's talk about some challenges with VFD environments and physical access. So there are challenges for VFD installations, and some of those are, loud, dirty environments. There could be airborne contaminants. The floor around VFDs could be slippery. It could even be cold, like if you're in the environment in a warehouse or a food storage area. If they're installed around large machine tools, you could have this oil mist in the air and moving equipment and things that are sharp that you just don't want to be around. So shutting down for a tag out or a lockout or an accident can cause costly waste and actually reduce the firm's profit by the minute. So this is one of the benefits of using a mobile apps. We'll talk about this in future slides here, that we may be able to perform some activities with a VFD without actually performing a lockout tagout function. That's just environment, and then there's these hard to reach locations. One example might be a conveyor in a mining application, and often VFDs are installed in or around the conveyor itself, and this is moving equipment. The conveyors could be exposed to heavy dust or whatever is going on with that mining activity. And it could be difficult to get at the VFD, or crawling in or around a conveyor can be a dusty, kind of dirty endeavor. Another example might be a textile manufacturer. They could have airborne chemicals or finishes that if you open up an enclosure where a VFD is installed and you let those airborne things into the cabinet, it could potentially, damage these sensitive circuit boards if the VFD is left for extended periods of time. And that's why a lot of firms will install a VFD inside of a protective enclosure that's suited for the environment that VFD is in. So let's talk about how VFDs can help with access. So instead of approaching a VFD directly to use the HMI, you could connect the VFD with a mobile app by Bluetooth to check its status or diagnose faults up to 10 meters away or 32 feet. You could use a wireless connection to the drive to avoid having to open up that cabinet that we just talked about and possibly contaminating the VFD. Or even keeping yourself out of that harsh environment as a person. It's not fun to work in difficult physical positions or environments where we may have to wear respirators or other types of things. A Bluetooth connection with a mobile device does overcome some of the challenges of opening a VFD enclosure to do certain activities. And most mobile apps for VFDs also support some form of wired connection as well. Even with a wired connection, we can still leverage all of the benefits of using our smartphones and a mobile app because it's still better than typically a standalone HMI because you're interacting with a more full-featured mobile application. Another thing everybody's interested in is saving time, and time is money. Taking the time to perform a proper lockout, tagout procedure is important for safety, for sure, and I'm not saying we shouldn't do lockout, tagout. It's something that is necessary to protect people and equipment and everything from injury or damage. With a Bluetooth connection and a mobile app, we can avoid some tasks that would normally require lockout-tagout. Today's VFDs come with a multitude of onboard like diagnostics. And if the VFD is not connected to an industrial network where that information can be accessed remotely, then the typical HMI mounted on the front of the VFD is really your only option. This can mean performing lockout, tagout, or equipment shutdown to make the area safe to access. So one example I provided here is a stamping press where maintenance personnel could check drive diagnostics with a wireless Bluetooth connection from 30 feet away. That can save time and productivity by avoiding the need to interfere with equipment operations. This can also be the situation for facilities with very few standalone VFD applications or installations. And less time spent performing lockout, tagout to do certain functions means that it's better for everybody. So the technician could, for example, stand safely outside the exclusion zone of the equipment to monitor the VFD or check its fault history. So this next slide I had a little fun with. So let's not be like Tesla and aspire to make powerful death rays. Now, Tesla made great contributions to science, but one interesting fact is that in the 1940s, a controversial article about a death ray for planes in the New York Times created a bit of a public stir between J. Edgar Hoover and the FBI. Now, I may be making a little light of it, but what this slide is about is a serious thing, arc flash. So those involved with VFDs know that we want to keep the energy inside the system and not let it out into the open air like Nikola Tesla. In the early 80s, a paper titled The Other Electrical Hazard, Electric Arc Blast Burns by Ralph Lee was published in the IEEE Transactions on Industrial Applications. Now that paper helped a lot of people realize the hazards from arc flash. And since that time, a lot has changed with how we work around VFDs and actually any electrical equipment that could produce harmful arc flash. Several industry standards exist today concerning arc flash and protecting people from that injury. And I've just listed a few of them here for you to reference. And a lot of you in the audience might be familiar with a lot of these standards. So compliance to these arc flash standards means use of personal protective equipment or PPE. So putting on this clothing, as you can see in the picture here, to perform work on VFDs can be difficult and actually take a lot of time. And that's often the case when personnel have to like open up a cabinet where the VFD is contained. And we care about PPE in this session because I'm going to be talking about some activities that we can do with a mobile app and Bluetooth that can reduce how often we must wear PPE. And by no means am I saying we shouldn't wear PPE and it's not a good thing. I'm saying that if we can reduce how often that we have to put on this gear to do some pretty basic activities with the VFD, we can save a little time and it can be more convenient for us. So one of the ways to do that, and I don't want to neglect this, is to, one of the things we can do is access the VFD if the HMI or the keypad is mounted on the door of the equipment. And many manufacturers will sell these HMI kits to cut a hole in the door and mount the HMI on the door of the enclosure. That means you don't have to open up, say, the enclosure where the VFD is actually placed to just check some status or look at the product or to see a fault code. You may only need to put on some safety glasses or some lightweight personal protective equipment to do those basic functions. However, installing these door kits often involves the added expense for specialized hardware from the manufacturer to mount the HMI, and as I said, it requires cutting the door. This also may not be the best solution if you have, as I show in the picture here on the bottom, a lot of VFDs installed in a single cabinet. This could also be, for standalone VFDs installed inside a cabinet, maybe one or two, if a facility only has a couple of them, making that HMI available on the outside and accessible to the users is a benefit. But there is a way to access the VFD settings in these installations without opening the cabinet, where an HMI may not be installed or built into under the exterior of the box. We could use a mobile app with Bluetooth and from a manufacturer that provides that. And I've even had some experience in the field, even if the keypad, which in the case of this one manufacturer here that actually contains the Bluetooth transmitter, is inside the enclosure, you're still able to access. The Bluetooth is still powerful enough in some cases where you can stand just a few feet away from the enclosure and be able to get a signal to the VFD behind there. The normal line of sight Bluetooth range is typically about 30 feet. So you could, like I said, adjust settings, collect diagnostic data, and avoid the need to open that cabinet door. And I'm not saying that I'm not saying you can do everything, all the activities that you need to do with that VFD, but there are some that you can do without touching or dealing with the actual VFD hardware itself. If you do open a cabinet door, you're going to have to wear PPE, like for routine maintenance, for cleaning the fans or checking electrical connections, or even troubleshooting failed electrical circuits or for fuse replacement. So like I said, there are some benefits, but you can't completely negate the need to get at the hardware of the drive in some instances. So what can we do? And I touched on a few. Even if the VFD has an HMI installed on the enclosure door, a mobile app can still provide a much better interface compared to the VFD HMI. There are some examples of a mobile app here on the screen and Bluetooth. I show some trending and plotting that can be easy and convenient. And this assumes the manufacturer provides this mobile app with these features, and your experience with different manufacturers' mobile apps can vary between manufacturers. You can do parameter settings, adjustments, monitoring, fault code history, backup and store the parameters, motor tuning. You typically don't see this on a HMI display where you can plot and trace various waveforms and things going on with the VFD. Recall from our earlier discussion in the session, we talked about some of the benefits of the smartphone and touch screens and high-resolution displays. So a lot of mobile apps for VFDs leverage the mobile device screen real estate and that high resolution to give us features that you just can't build in easily to an HMI interface. Again, another example is, hey, you could back up and restore settings to a free cloud service, which I'm going to go into a little later, or access embedded instructions. Now, we're talking a lot about Bluetooth and wireless technology and mobile apps, and I think I would be remiss if I wasn't to give you a good note on the security of using a mobile app and a wireless connection with your VFD. And as we discussed, a lot of these VFDs are installed in mission-critical applications, meaning Like if they stop working properly, they can have a significant impact on whatever process or equipment the VFD is controlling. So imagine the example of a VFD installed as a pump for a water tower. If that pump stops working and the water reserves in the tower are consumed, homes or businesses might lose water pressure. So we should take steps to maximize the security of our Bluetooth connection to the VFD and be just as cautious with a mobile app excuse me, as we would with pressing buttons on a VFD's HMI. Here's some tips. So don't make the Bluetooth pin an easy-to-guess code. I've given some examples here. You might ask yourself, well, what is 1472? That doesn't seem like an easy-to-guess code. Well, a colleague of mine reviewing the presentation suggested that this is just like a straight line down the left-hand side of a numeric keypad and then the button 2. So even numbers that wouldn't be obviously, easy to guess might be because of the finger pattern used. So you want to lock out your VFD's HMI keypad with a password if you plan to, in addition to the Bluetooth pin that you're using to secure the connection. And you do want to password protect mobile devices that have a VFD's mobile app installed on it, especially if you're using that mobile device frequently in your facility or in that environment. And then you might not want to loan out your smart device or mobile device to others if you know that it's a tool that you use in your work and it could potentially or inadvertently change some drive settings. So these are just some things. I'm sure there's more. This isn't like everything, but I wanted to make sure I mentioned security over Bluetooth here. So one of the things that I'm really excited to talk to you about in this next topic is a VFD, having hundreds of settings and parameters, making it capable of a wide variety of applications, being able to set up that VFD for installation in a comfortable environment without time pressures we often encounter during installation. That could be a huge benefit. So pre-programming that VFD before it's installed actually makes a lot of sense for many reasons. It's an excellent service, so it saves times for the installer, simplifies build time for OEMs possibly. Distributors or VARs or value-added resellers can stand out among the competition by pre-programming the VFD for some customers that might request it. However, doing that before installation does have some challenges today. So what makes that so difficult? VFDs, as you know, require, in most cases, three-phase industrial power. And that's high voltage. So that means 230 volts, 480 volts in our region, even 600 volt or higher, has to be available to and wired to that VFD to simply program it. That's really inconvenient if you're looking at a VFD on a distributor shelf somewhere that needs to be programmed. It can also be unsafe and cumbersome to do so in a warehouse location, for example. And three-phase power might not be readily available in that location. So wiring the VFD to power it up can be time-consuming, require electricians or qualified personnel, and any benefit of programming that VFD in advance of installation is kind of negated by the burden of having to hook up all of that wiring. So doing that activity for large quantities of VFDs is not very efficient and makes it undesirable, actually. So I do want to indicate here there is a solution. Recently, one manufacturer offers a solution using your handy smartphone for this. It's now possible to program the VFD with your Android smartphone without applying dangerous main circuit voltage. One manufacturer uses a USB cable and a mobile app on your smartphone to power the VFD's processor for programming while it remains inside its packaging. And using your smartphone and a mobile app to access those settings with low power is actually safer, more convenient, and it could even be a way to diagnose some failed VFDs returned for repair without having to hook up main power. And again, this keeps the VFD in its original packaging. No special electrical personnel or equipment is needed, only an Android device, a cable, and a mobile app. I think we're now in a position to allow distributors, OEMs, or value-added resellers to provide those enhanced services and pass those on to the eventual owner or installer of the VFD. And did I say we can do this with our trusty smartphone and we don't have to have special, keypads or other types of special equipment from the manufacturer? So it may sound like I'm selling this, but actually I am. The benefits are really great for doing powerless programming of VFDs for their eventual application. Another thing we want to talk about is backup. So VFDs have hundreds of settings like I talked about. Setting those up for some processes can be complex and time-consuming. Engineers would like this to be a one-time activity, and in a perfect world it would be. Programming those settings can occur actually more frequently than just commissioning of the VFD. So VFDs do have a service life. It could be 10 to 20 years or even more. So large VFDs can be quite expensive compared to the smaller VFDs. And so the more life we can squeeze out of those, the more it pays for itself many times over. So replacing circuit boards may require reprogramming, having a setting record, or even better yet, having a backup file that can be quickly restored is a recommended practice. The reality is qualified personnel aren't always available when a VFD fails. So, and setting records or backup files are often neglected, and this can cause more time to be taken to replace a VFD in often crisis situations. So some failure examples, power surges, contamination, component failures, wiring errors. What we want to know is how can we make backup and recovery of VFD settings more simple and efficient. So let's talk about that. You could have a spare VFD on hand. You can centrally store a setting record or backup and note where that setting record is stored on or near the VFD. Document or restore procedures so people that haven't seen this VFD hidden away in an enclosure somewhere for many years can follow the steps to do that. The one thing that I'm talking about today here mainly is expediting that recovery using a PC tools or mobile apps. So that can help service personnel quite a bit in bringing that VFD back into service. You do want to keep your VFD setting safety stored. Consider using a cloud service. Some manufacturers offer a free cloud service. I might know one. At least one manufacturer integrates cloud service, like I said, with their VFD mobile app, and that's a huge benefit. As a bonus, you could actually back up and restore your VFD over a wireless Bluetooth connection if that was the case. So this is a real benefit. Keep your parameters safely stored, and consider using some of these tools and seeking out a manufacturer that makes this a simple and easy process for you. Some of us may ask whether or not we should use cloud services. Cloud services to store VFD settings, the need for that can vary between businesses. So let's look at, service providers that maintain VFDs at multiple locations, firms that need speedy recovery of VFD failures, which is likely everybody, maintenance personnel, and so on. So even facilities or industries that may only have 1 or 2 VFDs might find this a benefit. I did want to note quickly that storing your settings for your VFD may be more desirable for some firms that don't want to expose those settings outside of their business or their firewall. And some firms may have an existing parameter management practice that they just prefer to stick with and not use a cloud service. And often a lot of this could be done over, like I said, an industrial network. So regardless of the method that's used, a mobile app does give the user the option to decide, in a lot of cases, where to store their settings, either locally, on the mobile device, on their network, or in a free cloud. It's a great feature. The other thing that can be done is where are the product manuals located. So the VFD or the mobile app that I'm familiar with, you can have product manuals embedded right into the mobile app that you're using to work with the VFD. And these manuals that are packaged with the VFD are often focused on just the installation and the initial setup and test operation. So having full instructions for that VFD's features that may have hundreds of different settings in it in your pocket and on a mobile device is really handy. A lot of us have tried to pinch and zoom a letter-sized PDF on our smartphone. That's not the best formula because you're doing a lot of pinching and zooming and scrolling. So that's one of the pitfalls of just looking at PDFs, which are really designed for printing on a mobile device. Here's a screenshot of one manufacturer's solution for manuals on a smartphone. In this case, they've provided a product instruction section which delivers the information in HTML5 responses. So you can tilt in landscape or portrait, and the content adjusts itself for the size of the mobile device. And here's just more screenshots of, say, fault codes being displayed and embedded helps being displayed along with the mobile app for that VFD. Let's take a short walkthrough of the DriveWizard mobile app provided by Yaskawa America for the new G800 series AC drive for industrial applications. Now, I can't speak during the video, so I've added some text to the demonstration to help explain some of the features. And basically, I walk you through some but not all the capabilities of this app that was released in January of this year. So sit back and relax for the next few minutes. I'll rejoin you at the end of the video and conclude and recap what we learned today. And at this point, the moderator can play the video demonstration. All right, the video's done. Let's go ahead and pick up on the next slide. Okay, so that was a quick demonstration of the Yaskawa mobile app. I do want to get to some of your questions because we had a lot of good questions involved here, and we only have a few minutes left in the presentation. I did have a recap to talk a little bit about what we learned, but I might skip a little bit of that recap to answer some of your questions. But I do want to hit on briefly future-proofing because that wasn't the title. It's pretty simple. You want to look to future-proof your VFDs. You want to look for VFD manufacturers that provide a robust mobile apps for their VFDs that they sell, and even a wireless Bluetooth connection is highly desirable. Free cloud service is something else that's a great benefit. And manufacturers that provide these things today, they're evolving. They're looking at new technology, as they should, to overcome many of the challenges that we discussed. So consider that in your next VFD purchase, and those are just some things you can do to future-proof your VFD. Not everything, but some. So why don't we only got a few minutes here, and I know we've got a couple slides at the end. Let's go ahead and hit some of these questions. I did have a question about one moment, stand by.
Great, Michael. So if you want to go to Q&A, let's just click through the summary slides quickly. Why don't you go ahead, click through those so people can see the rest of the slides.
Okay. So this is just a summary of what we discussed. There's a lot of things in the presentation, and you'll be able to download this later to look at it in more detail.
Excellent, thanks. So we'll go to the Q&A right now. Thank you, Michael, for your presentation, the tips, the application, discussion, and demo. The audience may type questions for the presenters in the Ask a Question box on the screen, and we'll get to as many as time allows. Questions we don't have time to get to will be posted online at controleng.com with the archived version of this webcast. Remember to download a certificate of completion or copy the presentation. Use the Event Resources tab on the left side of your screen. And now the questions.
Okay.
How are the Bluetooth connections affected by being inside a metal VFD enclosure?
Actually, this is a really good question, and the answer is it depends on the enclosure type. One of the pictures that I showed in the presentation showed an enclosure with kind of a plexiglass front cover. Some of the enclosures I showed were completely metal boxes, and of course we know that a metal box will block radio frequencies. So to the extent that that enclosure lets out some of these radio frequencies is the extent that you'll be able to communicate by Bluetooth with that VFD. So it's kind of case by case. And my experience has been, even with typically a fully sealed metal enclosure, you can still stand 1 to 2 feet away and make that wireless Bluetooth connection.
Great. That was the next question, was how does it affect the range of the Bluetooth connection? I think you mentioned a number during the presentation as well.
Yes. Yeah, it's a couple of feet. And again, it's case by case, and I can't pin a specific number, but the Bluetooth in the Yaskawa product that was demonstrated is the spec of 30 feet under normal use, right?
Another question, can you save the parameter set in the app to quickly program multiple VFDs the same way?
Yes, you can. And again, this varies by the manufacturer's app. So we could save multiple backups and restore that parameter to the same series of that parameter set to the same series of drive products today.
And then here's a question about the type of phone for the programming. Okay, why not an Apple iPhone also?
Right. I think this question, if I'm reading into this a little bit, is more geared towards the power off programming capabilities that I talked about being a great benefit. And I mentioned specifically Android device to be able to accomplish that. And the reason for that is that the Apple devices, what's needed to communicate with the drive is what's called USB on the go. And to provide power to power up the CPU from the mobile device, Apple just doesn't support that feature of USB on the go and that type of a wired connection on their devices. So it's not really a restriction from the manufacturer. It's a restriction from the VFD manufacturer. It's a more of a restriction from the mobile device manufacturer. So Android devices right now can do the power off programming.
Great. And one more question quickly, specifically, if I already have a partner account for Yaskawa.com, can I use it for Yaskawa Drive Cloud login?
The answer is no. The accounts are separate today. So when you sign up for a Drive Cloud account, those credentials will be different than the Yaskawa partner account. And it's something we may evolve to in the future to make this a more seamless experience for our particular customers.
Well, great. Thanks, everyone, for the great questions. And thanks again to our speaker, Mike Hall with Yaskawa, for sharing his time and expertise with us today. I'd also like to thank our sponsor, Yaskawa, for sponsoring today's event. Now that we're just about done, we do want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. On behalf of Control Engineering, Plant Engineering, and CFE Media and Technology, I'd like to thank you for attending. This concludes our webcast. Thank you again, and goodbye.